but in 1972, when Gerald started the company, they started selling crane monitoring devices in the United States. Those systems were all developed and manufactured in London, a company called Wayload Limited, which Greer Company became a dealer for. And of course, those systems were all these mechanically perimeter measurement devices, load angle, length, load radius, that type of thing. There was a lot of use of things like speedo cables and bells and whistles and cranks and things like that back in those days that made things really hard to calibrate, but yet they were accurate. You know, they were good devices and they were accurate, but they had long, hard calibration processes. Such as this Kruger system was one of the first systems that had all three types of systems in it. Had the hydraulics, the electrical, and then they used a cam in here for a load chart as a mechanical device. Well, here in '63, this Wayload Limited company in UK, they started using this Wayload line measuring system. And this is where we came in and we had things like the bell cranks and the speedo cables and little electric gauges and lights and things like that you would use to monitor the perimeters of the crane. Okay, back in the '72, at that time, the systems sold by Greer consisted of load indicating devices, boom angle indicators, things of that nature. And Gerald wanted his own load measuring device, so he invented this line rider technique that used a Wheatstone bridge for measurement. And in the '80s, everybody was buying everybody, right? We got these English companies, they're over there buying everybody over here is buying everybody. This all come up in this company called ECO, based in England, and ECO developed the first microprocessor-based load moment system. This was back in the early '80s. So Greer Company right away volunteered to be the U.S. distributor for this system. And you can see this system in the picture right here. This is an old MicroGuard 3A system that we had a lot of OEM manufacturers started using. And here is a processor board from back in that era, which would wind up having, 4 or 5 different chips in there to store memories and stuff, and fairly fast processors for the time, okay? So they kept going with this, and then came the 3As, the OEMs got involved in it, and in the latter '80s, this Morgan Crucible company purchased ECO, and it became Morgan Electric Instrumentation, MEI. They also purchased the Greer Company. So at this point now, the Greer Company was owned solely by the English. There was no American ownership of Greer Company anymore. So eventually, all the load moment systems design and development was relocated from England to the Greer Company, United States. Along with that, we got a bunch of English people in the engineering part of it, started using them on the engineering part of it. The new product design and manufacturing all done at the Greer facility in Santa Ana. So you can see they're already in that facility that I was in for years. So while promoting and selling the microprocessor systems, Greer also continued to develop their own systems and came up with things like the rotation indicator, the load systems, and the load length and angle systems, radio NE2 blocks, all these types of accessories. So Gerald was pretty much at the height of his career during all this, and he was starting to wind down a little bit. And then along came the MicroGuard 400 computer. This computer was engineered by some of our English engineers. Some things that happened, there was less memory chips in this 400 computer. The processor got faster. The processor in these was probably looking at the configuration of the crane about 3 or 4 times a second. Okay, you can imagine that when you've got this big old boom in the air and you're booming down like this, and you're monitoring that signal 3 or 4 times a second. You know, that holds that accuracy in there pretty good. So this computer system was used extensively by the OEMs and the aftermarket. There's lots of these, there's thousands of these 400 computers in the field today. And they're obsolete today. Actually, they're no longer manufactured. Parts are getting harder to come by. Along with the 400 series displays, there's a lot of these displays that's become obsolete since this. So here's what happened in the marketplace. The OEMs were always searching for systems that let them do things faster. Okay, as they manufactured the crane, the old 400 systems, every single crane had to go across the test pad to be calibrated. Okay, every single crane. So in 1999, Gary Knight, who's no longer with us now, was chief engineer back then, he developed what we called the MicroGuard 500 series computer, which is the same computer that we're using today. The result of this, you can see the computer is much smaller than the 400 series was. It has a single board in it. The transducers are incorporated into the computer instead of hanging out on the cylinder and being wired in. So that got rid of a large wiring chore there. The thing that the OEMs really liked about this, there's quite a few of them actually. One of them was a single computer could go for any model of crane, okay? Because all of the crane information was stored on a single EEPROM in the computer. Okay, we would go through the transducers are calibrated and matched to the board. So you take this computer out of the box, it already knows how to weigh a load, you just don't know who it is, right? So you take the EEPROM with the information and you plug it in, and suddenly now it knows it's an RT160 and it's got this 120-foot boom or whatever it is, but it doesn't know where to start and stop, okay? So that's where it came in what we call the fast calibration, where you teach not only how long the boom is, but you teach it where to start calibrating and where to stop, or measuring and where to stop. So zeros and spans became just these OEMs went crazy over it. You know, where you could go out and calibrate this crane in 45 minutes. That's phenomenal for this OEM that no longer has to calibrate every single machine. So that was pretty much the way the 500 computer started. And I'll tell you this, I came to Greer in 2000, so I came right in on the tail end of the invention of this 500 computer. So of course, right away, the beginnings for me was the MicroGuard 500 computer and making up classes for these OEMs and customers and things like that, and actually learning this system. So I didn't get a really, really good education on the old 400 system as far as working on them and stuff like that. So, in switching to this, we also changed styles of displays. In 2000, after we were purchased by Tulsa Winch Group, the engineers were instructed that we were to upgrade these displays. So for the boom truck industry, they came up with this display called the MicroGuard 586, which I always like to say, as far as I'm concerned, it's the best friend the small crane operator ever had. You know, I came up in this small crane boom truck industry, and we used to have nothing but the seat of our pants to operate by, you know, you pulled until the truck tipped and that was enough, right? So this MicroGuard 586 gave them a very, very accurate tool to work with. Back in the 400 series computers, we had what they called RCI 500, which you see right here, was a display that was built specifically for Terex. And that display was kind of a victim of the times. It wasn't a real good display. The LCD in it tended to turn black in sunlight because it was the wrong type of LCD, and nobody took time to test it well enough before it went into the field, okay? So Terex decided to go with this RCI 510 as their flagship display, and they started pulling all of these RCI 500s out of the field. So it was all replaced with the RCI 510. The color display you see down here in the corner is a display that was designed and built specifically for link belt, and that was to replace this MG 434. Which you can see the 434 had the same kind of glass in it as the RCI 500 did, and basically the same set of problems. So those two displays were obsoleted out and replaced by these newer displays. Now since this, Link Belt has gone out on their own, and they have pretty much stopped using Greer systems and put their own system in, which is a nice system. You see it? It's a nice system. Yeah. Gary Malco ramrodded it too, but they took my help. Gary Malco worked for me for 8 years, and he's really good. You know, he's ramrodding all these programs for Link Belt now. So anyway, moving on. In 2012, Greer made the decision, well, Terex helped us too. You know, we kind of made this decision along with our customers to go in with the color displays, a full VGA color with a CAN bus system instead of the hardwire communication system. So the OEM production in this display for Terex started back in 2012. And now they're in full production with the Insight and the Element displays, okay? And I've got separate PowerPoints on all these as we go along too, so don't let me confuse you by running through all this stuff. So let's bring it up to date as to where we are today. You saw the facility that we started in about 4 or 5 years ago. The management decision was made that they wanted to incorporate all of the Tulsa winch companies under one roof, okay? So Greer Company was moved into this large 265,000 square feet unit in Jinx, Oklahoma. And this is a phenomenal facility. You just can't believe this facility. You've been through it, haven't you, Brian? It's just unbelievable. Until you go through it, you just get lost in it. And there are so many neat machining things and stuff going on there, you know, it's just unbelievable. So this has, I guess in some ways, upset some things, but it's also getting better and the communications are coming together. They just got through rearranging all of the work groups. Were you aware of that? I mean, all this movement that's going on. Jim Zartek has pulled all of the engineering and sales groups together and things like that in efforts to get the team play working, you know, get everybody working as a team. So there's a lot of things going on there. And myself, I still live in California. I work out of a product support office out there. And under that roof, you can see we have DP Winch, Gear Products, which was the most recent acquisition, Greer Company, Tulsa Winch, and a Canadian company called Landtech. I think there's 2 Canadian companies. Here is the new facility that went up in September of 2011. a 110,000 square foot facility in Vancouver. And that houses Pullmaster and Landtech. There's the other one. This Landtech is kind of a large winch manufacturing company, and Pullmaster's specialty winches. And then, of course, the Gear Products winches are the ones a lot of the OEMs use. So that's the various companies that's in. Just for your information, this is kind of the reporting order of all that. You see all of this is owned by Dover Corporation. Dover is a huge conglomerate of hundreds of companies. And I'll tell you what, they're really a good company. I really enjoyed working for them. They're the kind of company that when they go in and take over companies, they like to keep the management intact. You know, some of them go out and fire all the management and all this, you know. Dover was never that way. They wanted to keep the management intact and work with them on their individual product knowledges and bring it together. So Dover is the chief. TWG is the owner of all these companies you see down here. Tulsa Winch, TP Winch, Greer Company, Gear Products, Pullmaster, and Landtech. So all those are under one command at this point. And that's present day today. That brings us up to present day today. What we do is build these cornerstone systems. Lift, pull, and rotate. That's what we're called anymore. Vehicles, small to large, service truck, cranes, boom trucks, rough terrains, all terrains. 3 years ago, I was at Miller Industries in Tennessee, calibrating booms for wreckers. You know, the military was buying these large rotating wreckers, and we were putting load moment systems on these. You know, so this is getting lots of diverse things going on.